Welcome to another session of Engineering Economics, Inen 2373. In this video, I'm going to talk about the cost of capital and its relation to the minimum attractive rate of return. We have seen that the minimum attractive rate of return is a rate that we use to discount the cash flows that we will receive in the future for projects and how we use those to evaluate the present world and how we use that to compare against the internal rate of return. But the question is, how do we compute this minimum attractive rate of return? Well, that has to do a lot with two things. One is the sources of finance and the level of risk. When corporations, say corporation XYZ, needs to finance projects, corporations have different alternatives to get funds from, and they could get loans, bonds, or other investments from the owners. And this cash goes into the corporation that it's then later put to work into an idea, and this idea is implemented in the shape of a project, and that project should be paying back the corporation this return, which we call the minimum attractive rate of return. Now, of course, the bank, the bondholders, and other investors who have shares, all of them will want a return on their own money. Well, the minimum attractive rate of return should be placed in such a way, should be calculated in such a way that the percentage that the company gets back from the project out of the initial investment should be enough to pay the investors, the bondholders, and the bank loan. And on top of that, the expectation should be that corporation XYZ, in most of cases, it should grow by means of implementing this project. So the minimum attractive rate of return should be larger than the average of the percentages that we need to pay in terms of loans, bonds, or to the shareholders. And that's the key concept. Now, so those are the relations. So the next question is then, how do we compute the weighted average cost of capital, which is the one that we're going to use as a benchmark to compute the minimum attractive rate of return. And to answer that, we're going to propose a numerical example, but pretty much the idea is to use the effective annual rate that these loans, bonds, and dividends to the shareholders are implying. And also we're going to consider the effect of the taxes on bank loans and bonds, because that's going to be a very important way to reduce our weighted average cost of capital. So in this example, let's consider the sources of finance for this company. The total amount to be financed is 10 million, and we're going to have a bank loan, a bond, issuing bonds, and the shareholders will invest more in the company. So the bank loan is for 5 million. The rate is 10% per year, payable monthly. The bonds are 3 million with a bond rate of 8%, payable twice per year. And the shareholders are going to contribute with 2 million. The average price per share is $20, and the dividends per share is $1.80 per year. Also, we need to know that the tax rate is 35%. So, since the total amount to finance is 10 million and the loan was 5 million, that's 50% of the total amount which come from the loan. That's why it's a weighted average, and we're going to multiply that times the effective interest rate for 1 year, and that is computed as 1 plus point. Now it's 10%, so it's 0.10 divided by the, we are making monthly payments, so that means that this is compounded monthly and then raised to the 12 because we are interested in computing the yearly effective interest rate. And this computes the yearly effective interest rate, and then we have some effect due to the taxes because we either pay the taxman or we pay the bank. We don't have to pay it both because the interest that we need to pay is a financial cost. So we subtract, since the tax rate is 0.35, we subtract 35% of this cost because we were going to pay taxes anyway if we don't do this project on the profits that we have. And since we need to finance this project, the financial cost that we incur by asking for the loan is reducing the profit, and because it's reducing the profits, we will not pay the taxes associated with those profits that are being reduced, and therefore we can assume that the financial cost is actually less by about 35%. Continuing with the example, we have bonds, and the contribution of the bond is 30%, 3 million out of 10. And now we have the effective interest rate for the bond. The bond rate is computed as 8%, but we're paying this every 6 months, twice per year. So we need to compute the yearly interest rate, which is 1 plus 0.08 divided by 2 to the power 2 minus 1. That's the yearly interest rate. And we have the same effect with the bonds because the bonds, the coupons of the bonds, which is the interest associated to paying this financial source, is considered financial cost, and that also have the benefit of reducing the profits and therefore reducing the amount of taxes that we need to pay. Finally, the effect of the shares is 0.2 times. Now we have a dividend of $1.8 for every $20 that we get back, that we get invested in the company, because that's the average price, and that's going to compute a ratio of how much we need to pay to the shareholders. But this one will not be affected by the 1 minus 0.35 because we don't have the benefit of the shares. Those computations, the dividends, are paid after the fact that we have computed and paid the taxes. When we compute these numbers, we can obtain the relative cost for using each one of these sources, and the number that I have for the bank loan is 3.4032%. For bonds is 1.5912%, and for the shares is 1.8%. Okay, hold on, let me double check that quantity. Okay, it's correct. And when we add all these quantities together, because the weighted average is the contribution of each loan, the bond, and the shares, this number is 6.7944%. One very important result that we have here, this is the weighted average cost of capital. One very important result that we have here is the fact that this weighted average cost of capital, if you look at it, it's less than either of the shares, the bond, or the loan financial cost per se before taxes, and it's a very important aspect because it's easier to finance projects simply because by asking with external sources, because by asking for money from external sources, then we get the benefit of paying less taxes on such projects. So there you go. That's how we compute a weighted average cost of capital, and the expectation would be that the minimum attractive rate of return would be somewhat larger than the weighted average cost of capital, depending on the level of risk. So how much of minimum attractive rate of return could be with a 6.79? Some people use maybe 3 points, that is 3%, so maybe 9.7, rounded up to 10%. Some people might even use 10 points, so 17% maybe. And that would be the minimum attractive rate, the relation of the minimum attractive rate of return to the weighted average cost of capital.